Math 3, Unit 2, Section D. This worksheet will be worksheet 4. Today we're talking about solving and graphing quadratic equations. What are quadratic equations? Shaped like U's, parabolas. Exactly. Okay, there are multiple ways to solve quadratic equations. When you are solving them, does anybody know, like, you know how you factor sometimes and then you get x equals a value? What is it, like, what does x equaling mean when you find those answers?
What would it be like, at what point would it be like on the parabola?
Mm-hmm. It's a specific point on the parabola, specifically the point where it crosses the x-axis, okay? Now, do you see here how it already has like a factored portion? You have a square. So one way is if you have a square like this, you can move things around and end up taking the square root of both sides. Anytime you take a square root of something, like you make the square roots, your answer becomes plus or minus. And so in this case, when you took the square root of x minus 3 squared, you get plus or minus the square root of root 3. And then to get x by itself, you add 3 to both sides. This actually represents two answers. It represents 3 plus root 3, and then also 3 minus root 3. But we oftentimes will just leave it as 3 plus or minus root 3 because it takes less time to write. And you can't simplify mathematically on your paper 3 plus root 3. Like, this is the simplified form because you can't add 3 with a root. Okay? The other way is to solve by factoring. Okay? And so remember with factoring that this middle number is your adding or subtracting number. And the end number here, that one is your multiplying number. And there's lots of different ways that you have learned to factor, and we're going to talk about some of those ways today. But hopefully most of you can factor. Do you guys remember how to factor? Okay. And then again, once you factor, you set those equal to 0 and solve. The most important thing, though, when you're factoring is that your equation needs to be set equal to 0. So you always have to move things left to make them set equal to 0. The last way is if you can't use either of those methods, then you have to use your quadratic formula. And this is something you should have memorized. And if you don't have it memorized, you need to memorize it. Okay? And again, it has to be set equal to 0. And then remember here, once you're at this point, your A value is 2, your B value is negative 3, and your C value is negative 7. This only works if your equation is set equal to 0 and is written in descending order. Descending order is when you start with your highest exponent and then it goes down to your lowest exponent. So notice that this is at x squared, this is x to the first, and then this is actually x to the 0 when x isn't even there. Okay, so now we're going to get on to the examples. Sound good? Okay, I actually want to start with the algebraic side. Okay? And so this says f of x equals g of x. So if we write this as an equation, we would write negative, and we have parentheses, x plus 3 squared plus 4 equals 0. So we took our f of x equals g of x, and now we're going to solve for x. So what would I need to do first here in order to solve for x? Good. Subtract 4. So remember, when you're solving equations like this, you're almost doing backwards order of operations. So you have to get rid of all the adding and subtracting before you can do multiplication and division. So now what would I do in order to get rid of the negative in front? Good. We have to divide both sides by negative 1. You are not going to distribute things here through a parenthesis. So these cancel. We get x plus 3 squared equals what? 4. And so do you see how the square is by itself now? Okay. So once your square is by itself, then we can take the square root of both sides. Now, since I am taking the square root, see how I am making the square root symbols? That means my answer is going to end up being what? Plus or minus. So we write this as x plus 3 equals plus or minus, and what is the square root of 4? 2. Very good. Now on this one, see how there's no roots here? Can I solve both of these equations? Yeah. So I would write two equations. We have x plus 3 equals 2, and x plus 3 equals negative 2. And then we would solve. So here I subtract 3 to both sides. X equals negative 1. Here I subtract 3 to both sides, and I get x equals negative 5. So when I'm doing my graphing portion, these should be the points that the graph ends up crossing the x-axis. Okay, so let's go over to the graph. So for f of x, we need to have our vertex. What would be my vertex here? Good, negative 3, 4. And my a value is at negative 1 over 1, which means I know that it would end up going down. So the other thing is we need to, I'm going to graph this actually first. So g of x equals 0, where do I go to write that line? Just right here. And it's really y equals 0, and we draw this line through here. Okay, and so now I'm going to go ahead and go left 3 and up 4. And make our point. And then we have kind of our 1 over 1. And with parabolas, you need to actually plug in values in order to find the exact point it crosses the x-axis. And so when it's absolute value and you have like your straight lines, you can use the slope the whole time. But with parabolas, you can't. And so that's why we're always having to plug in values. Well, in order to find where it crosses the x-axis, you would actually plug in 0 for y and solve. Do you see how we already plugged in 0 and solved? And so we know the points it's going to cross is at negative 1 and negative 5. And then we can draw our parabola going down. So with parabolas, it's important to make sure you understand the algebra part, because this is where it's going to tell you the exact points it crosses at the x-axis. And it crosses the x-axis when f of x or y equals 0, because it's not going up, right? So you get an x value and then the y value is 0. So that's why you end up plugging in 0 here, which is what we did over here. So my answers for this problem are negative 1 and negative 5. Okay, questions so far?
What about the A part where like x equals blank? Are you going to fill that in or no?
Sure. Negative 1 and negative 5. Okay, we're going to move on now. All right. Okay, so the same thing on this one. Let's go ahead and start with our f of x equals g of x. So how would I end up writing that? Good. 1/3 x minus 1 squared minus 3 equals 0. And you could do the 0 on either side. It doesn't matter. Okay. Is my square by itself? No. So what would I do next? Good. So I have 1/3 x minus 1 squared equals 3. Now we have a fraction again. How do I get rid of that fraction? Good. I like that. Multiply by the reciprocal. In this case, it would just be 3 or 3 over 1. Whatever you do to one side, you do to the other. These cancel. We get x minus 1 squared equals 9. What do I do now? Take the square root of both sides. I get x minus 1 equals what? Plus or minus 3. Now on this one, could I set this up as two separate equations? Yes, because there's no square root that I have to deal with. And so we get x minus 1 equals 3, and x minus 1 equals negative 3. Here we add 1 to both sides, and we get x equals 4. Here I add 1 to both sides, and I get x equals negative 2. Okay, so we go to graph. What would be my vertex on this one? Very good. 1, negative 3 is correct. My A value on this one is 1 over 3. And remember, when it goes wide, it's just telling you that the slope is going to be wide, but going up 1 over 3 and up 1 left 3 will not work. Okay? So that's why we have to plug in these values to find the exact point that it crosses the x-axis. So in fact, if you wanted to, we know that we could end up putting a point at 4 and a point at negative 2 because we know that's where it's going to end up crossing the x-axis. I'm going to draw my line for g of x equals 0. And then we can also plot our point at 1, negative 3. And then you can draw your parabola. Oh, when it's a fraction with parabolas, that's what I'm saying, it doesn't work out correctly. So if you were to go up 1 and right 3, it puts a point right here, and this point is actually not here. And so whenever it's a fraction with a parabola, you need to plug in values. So in this case, we plug in 0 to find the exact points it crosses. All right, any other questions? But it does, the A value still tells us, so the A value still tells us though that we know it's going up and we know it's going to be wide. The fraction is reminding us, okay, we know it's going to be a wider graph. Okay, so the A value still helps us that way. All right, are you guys ready to do just the algebra? Okay, so notice the difference like between this one right here and this one right here. Do we see how this one has a square and does this one have a square? No. So what do you think I'm going to have to do to this one? Distribute. Very good. So we're going to distribute. We get x squared minus 2x equals 35. And what will I need to do next? Good. Set equal to 0, and I would do that by doing what? Good. Subtract 35 to both sides. Okay, so I have x squared minus 2x minus 35 equals 0. Now, I know most of you can probably or maybe factor this in your head, but I want to show you a different way for factoring that's going to help you with number 4. Okay, just in case you don't know it. Anytime you're factoring, whatever number is in front here, and what number is really in front here right now? 1. You want to multiply these two numbers together. So 1 times negative 35 is negative 35. Okay, so now we're looking for a number that multiplies to be negative 35 and adds to be negative 2. What two numbers will work? Okay, so bear with me and write it this way right now, okay? So we're going to write this as x squared minus 7x plus 5x minus 35 equals 0. Because negative 7x and 5x really do make negative 2x, right? And they do multiply to be negative 35. Do you guys remember what you do when you have 4 terms? You factor by grouping. Do you guys remember factor by grouping? Okay, so we take the first group, and what could I factor out? X, and I'm left with x minus 7. Good. This second group right here, what could I factor out? 5. And I want you to write that as a positive 5. And what am I left with? X minus 7. Do we see how these parentheses match? Okay, do you remember how when they match, now it's really, I'm factoring out my GCF is x minus 7? Good. And so the answer is x plus 5 and x minus 7. Okay, and when you set these equal to 0, what does x actually equal? What is it? Good, negative 5 and positive 7 If you can do that in your head, you do not need to write it out, and I don't have room, so I'm not going to write it out right now. So x equals 5 and negative 7. All we're doing is setting our parentheses equal to 0, which we know they'll end up becoming the opposite values, correct? Yes, it should be actually. Thank you. The opposite value. Jen gets a candy. Okay, yes. Okay, so are we okay up to this point? Were you okay taking the GCF out? Okay, I'm going to show you the long way here really quick. Hold on, at this point. So at this point right here, when you had x times x minus 7 and a positive 5 and x minus 7, if you were, when you're factoring, since these are the same, you're taking out a GCF of x minus 7. And so what happens is you're really dividing each of these by x minus 7. And so these cancel, and you're left with x plus 5. Okay? And so I just kind of skipped this part. But when they have the same parentheses, those end up becoming just one parenthesis, and then you're left with the x plus 5 in the other parenthesis. Okay? All right, so this method on how I showed you here is going to help you with factoring right here. Okay, are you guys ready? Okay, well, before I can actually factor this one, we first need to what? Set it equal to 0. So I'm going to subtract x and subtract 5. Okay, so when I do that, I have 6x squared minus x minus 1 equals 0. Okay. Now, remember how I told you here how we're going to multiply the first and last term together? Correct? So we're going to do the same thing here. 6 times negative 1 is what? Negative 6. So negative 6 is the number I'm multiplying to be. And what number am I adding to be? A negative 1. Okay. Is anybody confused right now? Yes. Yes. So there's an x here, so I subtracted x over here, but there is nothing to combine it with, so it's just minus x. All right? Anybody else have anything they need explained? Yeah, G. Is there any way you can wait till we're done? Okay. So we're multiplying over like this. So what numbers would multiply to be negative 6 and add to be negative 1? So we're going to write this as 6x squared minus 3x plus 1x, right? Because do these, wait, thank you. No, leave it like this. Keep the 6 and then minus 1. So everything stays the same. We're just changing this. So these do add to be negative 1x, but we're just writing them differently. Okay? No. We're still keeping the same number that was here originally. We just took these to multiply together to give me my multiplication number. Okay, question. Okay. Okay, let's start over. Are we okay with being at the point 6x squared minus x minus 1 equals 0? Is that part okay? How we moved everything? Okay, let me show you something different. Well, kind of different. Do you guys remember the diamond method? Okay, so when you multiply, you're going 6 times negative 1. You have to multiply the front number and the back number. Okay? That number is negative 6. This number right here is your multiplication number. Okay? And we multiplied to get that number. It kind of makes sense. Okay? That's our multiplication number. This number in the middle, so whatever number is in front of your plain x number, that's your adding or subtracting number. And so in this case, that number is negative 1. And that number is your adding and subtracting number. So now the goal is, oh, you can't see what I'm writing, sorry. The goal is, you are trying to find, it's like a puzzle. What two numbers will multiply to be negative 6 and add to be negative 1? So, negative 3 and positive 2. When you add those numbers together, it makes a -1. When you multiply them together, it makes a -6. Do you agree? Okay, so at this point, we are keeping this the same and this the same, but I'm going to end up changing -x to be -3x and a +2x. It still makes -1x, but we're just going to expand it out. Okay, so I'm going to write this as 6x squared minus 3x plus 2x minus 1 equals 0. So all I'm doing is taking this x part and changing it into two different pieces. Is that okay? Is that better? All right. So at this point now, I'm just going to come right here. Is that okay? We're going to break this up and factor by grouping, just like I did in the first example. So this first group right here, what is the GCF? So we are taking out a 3x, and when I do that, what is left with that group? 2x minus 1. Good. Now, this second group, is there a GCF? No. But if there isn't a GCF, you can take out a 1. Exactly. And so my GCF is going to be a +1. And when I take out a +1, does it change anything? No. So I'm just going to write 2x minus 1. Do we see how these parentheses match? So that's now my GCF. We have 2x minus 1, and then the leftover portion, the part that's in front, goes into your second parenthesis, which is 3x plus 1, and that equals 0. Okay, questions? Do we get this? Okay, and so when you set these equal to 0, can you guys do these in your head? Setting them equal to 0? Okay. Yep. X equals 1/2 and -1/3. If you can't do that in your head, just set up your equations. 2x minus 1 equals 0 and solve. 3x plus 1 equals 0 and solve. Yes, that's a +1/2. It's just an equal sign in front. Okay. Okay, next problem. Are we ready for 5? Okay, what am I going to do with 5? Subtract 5 to both sides. 1/2, parenthesis, x minus 3 squared equals what? 2. Guys, focus please. How do I get rid of the 1/2 in front? Very good. Multiply by 2. These cancel. X minus 3 squared equals 4. Is the square by itself? Yes, so what do I do to get rid of the square? Square root both sides. Anytime I make the square root, my answer will be what? Good. So plus or minus what? 2. Can I set up two equations? Yes. So I have x minus 3 equals 2 and x minus 3 equals -2. Okay, so here I add 3 to both sides. I get x equals 5. Here I add 3 to both sides and I get x equals 1. So my answers are x equals 5 and 1. Guess what number 6 is? All right. I hear lots of little side conversations. I'm not sure if it's that you don't understand and so you're asking somebody in your group, or if you're just being rude, or if you're not paying attention at all. I don't know. So does anybody have any questions for me that I could help explain if you're not understanding? Okay, so let's move on to number 6 then. Okay, so first thing we need to do is what? Good. Add 1 so that it's set equal to 0. So we write this out and we have x squared minus x plus 1 equals 0. If I were to multiply the front two numbers together, 1 times 1 is 1. So my multiplying number is 1, and my adding number is negative 1. Are there any numbers that multiply to be 1 and also add to be negative 1?
Negative 1 and negative 1.
Because that would add to be negative 2.
Right, okay.
So there's none.
None.
When it doesn't work, we have to use the quadratic formula. Now, make sure when you use the quadratic formula that it's set equal to 0. So, in this case, A equals 1, B equals negative 1, and C equals 1. Questions? So the quadratic formula is on the other page, but to start with, it's negative B. So what's the opposite of B? 1 plus or minus the square root of B squared, so you'd have negative 1 squared, minus 4 times A, which is 1, times C, which is 1, all divided by 2A, which is 2 times 1. Okay, what is negative 1 squared? 1, so I usually will kind of go through here and write these answers. 1, and then negative 4 times 1 is negative 4, and 1 minus 4 equals negative 3. So I have 1 plus or minus the square root of negative 3 all over 2. Now, the square root of a negative number is called an imaginary number. Imaginary numbers are not real, just so you know. Most of the numbers that we work with are real numbers, okay? Yes? At this point, and later on in the year, we're going to get into imaginary numbers more. But at this point right now, because the only answer would be an imaginary number, we're going to say that there's no solution. And really, it's that there are no real solutions because there actually is an imaginary solution. Does that seem weird?
Yeah.
Kind of. But so for right now, we're just going to go no solution. But just know there is an imaginary solution out there. But it's imaginary.
So you
Okay.
can solve for it, but you can't solve for imaginary?
You can. We're just not going to in this unit.
Okay.
Okay? We only want real solutions. Okay. Yes. No, you would simplify if you could, but you wouldn't necessarily get rid of the fraction. Okay? Because really this is saying x equals this, and so x is already by itself. Okay? All right. Number 7. What will I do first?
Add, subtract 4x.
Good. So we have 3x squared minus 4x minus 3 equals 0. I always think that if I can factor it without the quadratic, it's much easier. So if we were to check this out and we go 3 times negative 3 and I get negative 9, and then I have a negative 4. Are there any numbers that multiply to be negative 9 and add to be negative 4? Nope. So since there is not, we have to use quadratic formula. A equals 3, B equals negative 4, C equals negative 3. So going through this.
Why is the 4 greater than the negative 3? It's less than.
I have no idea what you mean.
Well, because when you
It's
say you write in descending order, for like you're with like.
Descending order is by exponents.
Yeah. Okay.
Okay, so this is x squared, that's A.
Yes.
This is a plain x term, that's your B value.
Yeah.
And your C value is the one that doesn't have an x.
All right.
So descending order is always based on the exponents of your variables.
Okay. So.
A will always be at the x squared term, B will always be with the plain x term, and
Okay.
C will always be without a
All right.
variable.
I thought you said descending order.
But descending order is not by number, it's by exponents. Okay. All right. So negative B is what? Positive 4 plus or minus the square root of B squared, which is negative 4 squared, minus 4 times A is 3, times C is negative 3, all divided by 2 times A, which is 3. So now we're going to simplify. What is negative 4 squared? Positive 16. What is negative 4 times 3? Negative 12. And negative 12 times negative 3 is positive 36. And what is 16 plus 36 equal to? 52. Okay, so we have 4 plus or minus the square root of 52 all over 2 times 3, which is 6. Okay, if you can break down your root, you want to break it down. So anytime a number ends in an even number, I know that it's divisible by what number? 2. So this breaks down into 2 and 26. Can 26 break down further? Yes, 2 and 13. So I end up with a pair of 2's and a 13 left over. So this is 4 plus or minus 2 root 13 all over 6. You can reduce these numbers if all of the numbers and the one outside of the root, if they're all divisible by the same number. Can all those be reduced by the same number? Yeah, what number? 2. So that means that 4 divided by 2 is 2. 2 divided by 2 becomes 1, and 6 divided by 2 is 3. And so the actual answer is 2 plus or minus root 13 all over 3. Could you put 1 root 13? Yes, but you don't have to have the 1. All right. Questions before we do the last one? Okay, what do you think? Is this set equal to 0? No. So you have to multiply this out and subtract 4. Now, you should be able to multiply this out in your head. Do you know how? So, because I have x and x, I know it's x squared. Remember that these two numbers, that's your adding number. What is negative 3 plus 2? Negative 1, and then we give it an x. Negative 1x. And then you multiply those numbers together, and what is negative 3 times 2? Negative 6 equals 4. If you want to use FOIL or the box method, however you learned how to multiply it out, you can do it that way. But when you have it written like this, you should be able to do that in your head, right? Maybe? Okay, so next what will I do? Good. So I have x squared minus 1x minus 10 equals 0. Are there any numbers that multiply to be negative 10 and add to be negative 1? We only have 1 and 10 and 5 and 2. Can either one of those make 1? No. Quadratic again. Okay. A equals 1, B equals negative 1, and C equals negative 10. Negative B will be 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 10 all over 2 times 1. What is negative 1 squared? 1. What's negative 4 times 1 times negative 10? Positive 40, and 2 times 1 is 2. So I get 1 plus or minus the square root of 41 all over 2. And 41 does not break down, so you don't have to do anything further, and that's your answer.